Hello all and welcome to CAT VARC 100 series. This is RC number 2. The link to this RC was shared with you on our Telegram group. It was also sent to the registered email IDs of all enrolled learners. If you have not signed up for this free course yet, please do so on our website. Let's start discussing RC number 2. So the first paragraph says, the deep sea typically has a sparse fauna dominated by tiny worms and crustaceans with an even sparser distribution of larger animals. So the deep sea does not have many animals. The ones that are there are also tiny. Okay. However, near hydrothermal vents, areas of the ocean where warm water emerges from subterranean sources, live remarkable densities of huge clams, blind crabs, and fish. So typically, the deep sea does not have many large animals, but there is a special area within the deep sea, the hydrothermal vents, where there are large animals. Okay. So what is the paragraph summary? Hydrothermal vents in deep sea are exceptionally biodiversity rich. So they are exceptionally rich in biodiversity. Exceptional because typically deep seas do not have much fauna. Okay. Most deep sea faunas rely for food on particulate matter ultimately derived from photosynthesis falling from above. Okay. So most of the animals rely on food which falls from above. All right. And this food is produced mostly from photosynthesis. The food supplies necessary to sustain the large vent communities, however, okay. So most aquatic animals, most sea animals, the tiny ones, rely on food falling from above, the upper layers of water produced by photosynthesis, produced via photosynthesis and falling from above. But because near the vents we have large animals, author says that we need huge amounts of food to sustain these large animals. So it must be, the food must be many times the ordinary fallout. Okay, which means there are other, so there must be some other sources of food for these animals as well. If author says that this fallout, the food falling from above is not sufficient to sustain such large animals. Okay. The first reports describing vent faunas proposed two possible sources of nutrition. So there are two possible sources of food: bacterial chemosynthesis, production of food by bacteria using energy derived from chemical changes, and second source, advection. So first is bacterial chemosynthesis, or the second source is advection, the drifting of food material from surrounding regions. Okay, so animals residing in the hydrothermal vent regions obtain their food either from bacterial chemosynthesis or through advection. Advection means the food material gets pulled in towards these vent creatures. Okay. Later evidence in support of the idea of intense local chemosynthesis was accumulated. Okay, so theory 1, theory 2, theory 1 has evidence. Hydrogen sulfide was found in vent water. Many vent site bacteria were found to be capable of chemosynthesis, and extremely large concentrations of bacteria were found in the samples of vent water thought to be pure, which means these three are evidences to support theory 1 that these animals obtain their food through bacterial chemosynthesis. Okay. This final observation seemed decisive. If such astonishing concentrations of bacteria were typical of vent outflow, then food within the vent would dwarf any contribution from advection, which means the theory 2, advection, is probably not contributing to the food source as much as bacterial chemosynthesis is, evidence suggests, because many bacteria were found in vent water. So it is possible that the vent communities are obtaining their food from bacterial chemosynthesis. Hence, the widely quoted conclusion was reached that bacterial chemosynthesis provides the foundation for hydrothermal vent food chains. Okay, an exciting prospect because no other communities on Earth are independent of photosynthesis. Okay, which means the uh, the research or the evidences collected thus far suggest that the vent communities, the communities of creatures living near hydrothermal vents in deep sea, they are entirely independent of photosynthesis. They're not dependent on the process of photosynthesis for their food requirements. What they depend on uh, is bacterial chemosynthesis. The evidence suggests. Now, please note, all these sentences have been written in third person point of view and not in first person point of view, which means it is not author's opinion. He merely cites some evidences which have been collated thus far, and these evidences suggest that the food source is bacterial chemosynthesis rather than photosynthesis. Okay. So how can I summarize this paragraph? I'll have to include the idea that there are two theories and the supported theory is theory one. This is the gist of the second paragraph. So here is my summary. It could be condensed further, but okay. So the first point author makes, since particulate matter falling from above is insufficient, the food for these animals should come either from bacterial chemosynthesis, BC, here on, or from advection, drifting of food. Okay, so, and he also makes the point that evidence suggests that BC, bacterial chemosynthesis, is the more probable cause. Bacterial chemosynthesis seems supported by some evidences or some findings. Okay. There are, however, certain difficulties with this interpretation. Now. Here's a twist. So author explains first that bacterial chemosynthesis seems to be a likely source, and then he challenges this interpretation. He says, however, there are difficulties with this interpretation. What are they? For example, some of the largest sedentary organisms, sedentary means inactive, they don't move much. Some of the large sedentary organisms associated with vents, hydrothermal vents, are also found at ordinary deep sea temperatures. Okay, why is that a difficulty? I don't understand, but okay, let's read on. This finding weakens the theory that bacterial chemosynthesis is responsible for the food source. How? I can't make connections. But let's read the passage further and see if the author makes connections for us. Okay. So the large animals, large sedentary organisms associated with vents are also found at ordinary sea temperatures, many meters away from the nearest hydrothermal source. Okay, so this suggests, all right, so he's telling us that bacterial chemosynthesis is not a sufficient source for the nutrition of these creatures. All right, now it makes sense. So author is trying to say that if bacterial chemosynthesis was the source and bacterial chemosynthesis is possible only inside the vents, so the large animals should reside only in the vent areas, in the vicinity of these hydrothermal vents. But the large animals can also be found in other areas at normal temperature where bacteria is not present. Therefore, bacterial chemosynthesis cannot be the source of food for these animals. That is what he's pointing out. So that's a problem with this bacterial chemosynthesis theory. Okay. Another difficulty is that similarly dense populations of large deep sea animals have been found in the proximity of smokers. So large animals are also found in some other areas. Smokers, what are these areas? The vents where water emerges at temperatures of up to 350 degrees Celsius, No bacteria can survive such heat. Okay. So he's saying that extremely hot vents are also there in which bacteria can't survive. Still, large animals are found near these vents as well, which means bacterial chemosynthesis is not, playing. It cannot be the possible source of food for these regions. Okay, and no bacteria were found there. Okay, unless smokers are consistently located near more hospitable warm water vents, chemosynthesis can account for only a fraction of the vent faunas. Okay. It is conceivable, however, that these large sedentary organisms do in fact feed on bacteria that grow in warm water vents, rise in the vent water, and then reign in the peripheral areas to nourish animals living some distance from the warm water vents. So basically, he says that it is possible that it can be conceived that the extremely hot vent is not a hospitable climate for uh, large animals, and the large animals that reside, that they may reside there because nearby is another area of warm water and which is hospitable for these animals, and bacteria are present there, and they get drifted to, maybe they get drifted, the food produced through this bacteria gets drifted in more hospitable climates or surroundings where these animals can survive. So, okay, it is conceivable. However, nonetheless, finally, author says, nonetheless, okay, before that, what is the summary of the third paragraph? Clearly, he has stated the summary in the first line of third paragraph itself. He says there are, however, certain difficulties with this interpretation, and he points out two difficulties. Large animals, if bacterial chemosynthesis was, it were the source, large animals should reside only near uh, hydrothermal vents, which have high populations of bacteria. But large animals also reside in other areas which do not have hydrothermal vents at all, or which have hydrothermal vents at 350 degrees Celsius, extremely hot, where bacteria can't survive. So these are the two difficulties. In short, he's telling us that the BC theory, bacterial chemosynthesis theory, is insufficient to account for the food supply of of vent communities, essentially, or else large animals would not be found elsewhere. Okay. Nonetheless, advection is a more likely alternative food source. Okay. Finally, he says theory 2 is more likely an alternative food source. This is author's opinion, please note. First person point of view, author's point of view. Research has demonstrated that advective flow, which originates near the surface of the ocean, where suspended particulate matter, food particles, accumulate, transports some of that matter and water to the vents. Okay, so advection basically means drifting of the food particles from surface waters, from the surface regions to the vent regions, drifting of it. Okay, and that estimate suggests that for every cubic meter of a vent discharge, 350 milligrams of particulate organic matter would be advected into the vent area. So, if the vents are producing water, water, they're giving out water, then in place of what is taking the place of this water, particulate matter, which is coming in, it is getting drifted inside the vent region. Okay. So thus, for an average sized vent, advection could provide more than 30 kilograms of potential food per day. In addition, it is likely that small live animals in the advected water might be killed or stunned by the thermal shock or chemical shock, thereby contributing to the food supply of the vents. So the small animals might also get killed because of advection, because of this drift, this pull inside the vent, and they further provide for the food source of large animals living inside the vent. So this is, or near the vent. So this is the final stand of the author. So basically he says that, let's understand the thought flow now. He says Hydrothermal vents have large animals. Other areas of sea do not usually have large animals. Photosynthesis cannot be the source of food for these animals because it is insufficient. There can be two sources. Number one, bacterial chemosynthesis. Number two, advection. Bacterial chemosynthesis has evidences in support. However, it has difficulties. It cannot be the complete source, or else large animals would not live. And finally, he says advection, therefore, theory 2 is more likely to be the food source. This is the thought flow of the passage. So what is the main idea? What has he always tried to prove in the passage? This is the conclusion part. Remember pointer number 1 that I discussed in RC number 1 when we began this series. One pointer that we discussed is last part of the passage is absolutely important, very important in understanding the main point, in understanding the main idea of the passage. So advection is more likely to be the food source is what the author's main idea, main point is in this case. To the questions now. According to the author of the passage, which of the following best describes the source of nutrition for deep sea vent fauna? Advection is the source of nutrition. And please note one important link that author does not explicitly state. He says advection is basically drifting of food particles from surface of ocean inside towards the vent areas. And these food particles, particulate matter, is nothing but product of photosynthesis, which means what author is trying to say is bacterial chemosynthesis might be a source of food, but it is insufficient. Ultimately, photosynthesis is involved. Of course, through advection, photosynthesis is involved, is a source of food supply. Okay. Option A. The source of nutrition is independent of photosynthesis. Is that the author's point of view? That the source of nutrition for deep sea vent fauna is independent of photosynthesis. In fact, if author supports the advection theory, and advection is what? Drifting of food particles from the surface of ocean towards the vent area. These food particles which are getting drifted have been produced through photosynthesis, and that's exactly what the author wants to say. Therefore, the food supply is not independent of photosynthesis. This is absolutely wrong. This is actually contradictory to what the passage says. The huge amount of particulate matter falling from the sea surface, fulfills much of the need. Again, contradictory. It is not the particulate matter falling from the sea. That is insufficient. Therefore, advection, drifting of this matter, particulate matter towards vent, strong convection current, advection current rather, strong advection movement is responsible. A simple falling of particulate matter is insufficient as a food supply. So it does not fulfill much of the need, contradictory to what the passage says again. Factually incorrect. Option C. The drifting of particulate matter from surrounding regions fulfills more nutritional needs than chemosynthesis by bacteria does. Tempting choice. This option is tempting. That's exactly what the passage says. That's exactly what author supports theory to. He supports the advection theory. However, one problem with option C is this unwarranted comparison between theory 2 and theory 1. Whether advection provides more food or bacterial chemosynthesis does is beyond the scope of discussion. Author merely says that bacterial chemosynthesis, though there are evidences in support of this theory, it cannot be sufficient food, cannot be a sufficient source of food. Advection is an alternative food source more likely. Therefore, basically he's saying that advection also contributes to the food supply. He's not saying that advection contributes more than chemosynthesis does. Such a comparison is alien to the discussion. Tempting choice, but you can't find any tangible evidence for this comparison anywhere in the passage. And those of you who believe that, sir, who might cross question, sir, nonetheless, advection is a more likely, likha hai na, it's written that it's more likely an alternative food source. Now, please note that it's more likely an alternative food source. Alternative to what? Alternative to what? Alternative to chemosynthesis, bacterial chemosynthesis. So bacterial chemosynthesis is also there. It is at play. But wherever in regions where it is not at play, advection could be the alternative food source, food supply. Therefore, comparison between how much food is provided by advection, how much is provided by that comparison is never made. Both of them are there. Bacterial chemosynthesis alone is not operating. It is insufficient to provide food. Okay. Option D. Photosynthesis may play no smaller role. May play no smaller role, which means it is at least it has a significant role. Photosynthesis has reasonable or decent role to play. It has a decent role to play than bacterial chemosynthesis. So it's not. It has no smaller role than chemosynthesis. So it's at least at par or equally important as bacterial chemosynthesis is. That's a better way of presenting this idea. But you might ask, sir, photosynthesis, as explained earlier, the particulate matter which is getting drifted through advection is produced through photosynthesis. That particulate matter is being talked about. A beautiful question. Inferences are required. A clear understanding of what is being said, visualization of the entire idea is required to answer this question correct. So D is the correct answer, guys. The information in the passage suggests that the majority of deep sea fauna that live in non-vent habitats. So the deep sea fauna that live in non-vent regions have which of the following characteristics? All right. Option A. There were two things about them. They are large, but they don't depend on bacterial chemosynthesis. They could be large, but they do not depend on bacterial chemosynthesis. The non-vent communities, and most of them are not even large. Some of them could be large, but most of them are tiny worms and crustaceans. The deep sea typically has a sparse fauna dominated by tiny worms and crustaceans. The hydrothermal vents, however, have large animals, huge animals, which means one characteristic of the non-vent regions is that mostly there are small animals found, which means option B, the non-vent communities are smaller than many vent faunas is the correct answer. Comes from the first paragraph. Contrast is being drawn between vent communities and the non-vent communities. The common animals, commonly found animals, and animals found near the vent areas. Okay. Basis their size. Let's eliminate also. Option A. They do not normally feed on particles of food in the water. Well, to the contrary, they do. Because bacterial chemosynthesis is not available to the non-vent communities. It is available only to the vent communities at optimum temperatures. Okay. They derive nutrition from a chemosynthetic food source. Again, contradictory. Bacterial chemosynthesis is not available to non-vent communities. They congregate around a single main food source. Alien idea. Never mentioned that they congregate or they gather around a single main food source. Nothing like that is mentioned. Okay. Question number 3. What is the primary purpose of this passage? Do not forget the last part. He supports theory to advection theory. So what is the primary purpose? To support that theory. Let's see. Option A. To reconstruct the evolution of a natural phenomena. Is the author trying to reconstruct how a natural phenomena evolved? There's no talk about the evolution of any natural phenomena. This option is alien to the discussion. Nothing like that mentioned. Option B, the primary purpose of the passage is to establish unequivocally the accuracy of a hypothesis regarding food source of deep sea fauna. Tempting choice for some of you, because you see deep sea fauna, you see food source of deep sea fauna, you think this is what the passage discusses. You're not reading the entire sentence, however. The sentence, the option says, the primary purpose of the passage is to establish unequivocally. Is the author establishing something unequivocally? Unequivocal means conclusively, without any doubts, without any second thoughts, that this is certainly true. Is the author saying like that? Last paragraph, first sentence, he says, advection is a more likely alternative food source. So he's talking in terms of probability. It's a more likely food source. He's not establishing it for a fact. He's only speculating. Therefore, this part is exaggerated. Extreme answer choice. Extreme answer choice. Option 3, primary purpose is to survey, to discuss, to survey, to scrutinize, to analyze explanations for a natural phenomena. Okay. And determine which is best supported by evidence. Now, please note, author does survey the different explanations of a natural phenomena. What is a natural phenomena? Food supply. How do large animals or near hydrothermal vents in deep seas obtain their food? That's a natural phenomenon. What are the different explanations? Bacterial chemosynthesis and advection. So he's surveying them both, surveying explanations for a natural phenomena, and he's trying to determine which is best supported by evidence. First one, he says that yes, there is evidence, but it is insufficient, and finally supports the second one. So option C should be the correct answer, captures the essence and the blueprint, thematic blueprint of the passage. To entertain criticism of the deep sea research and provide an effective response. Is the primary purpose to criticize or to entertain criticism of the deep sea research, that deep sea research is insufficient, it is not happening, something like that? No. So this criticism part is alien to the passage altogether. Option C is the correct answer. Which of the following does the author cite as a weakness in the argument? As a weakness in the argument that bacterial chemosynthesis provides the foundation for the food chains at deep sea vents. Author points out a weakness in this argument. He does so in the third paragraph, where he mentions the large animals residing in the non-vent regions. If bacterial chemosynthesis was the primary source of food, then these large animals should not be present in non-vent regions. That is what he cites as an evidence that this theory is weak. Okay. Vents are colonized by some of the same animals found in other areas of the ocean floor as well. Correct answer. Exactly what we are looking for. So the animals that are found in the vent areas are also found elsewhere where bacterial chemosynthesis is not possible. So how are they surviving? That's a weakness in bacterial chemosynthesis theory. It cannot be the primary source of food, therefore, for these large animals, is what the author cites. Okay. Vent water does not contain sufficient quantities of hydrogen sulfide. Has the author pointed this out as a weakness? In fact, for this, evidence is available. He's already accepted the evidence in second paragraph somewhere. Hydrogen sulfide was found. So evidence is available. It's not a weakness. So this B is actually contradictory. Bacteria cannot produce large quantities of food quickly enough. Never mentions the speed of production of food. Alien. Author never talks about this topic, how quickly the food can turn out. Smokers are usually found in the vicinity of the warm water vents. Well, this is not a weakness of bacterial chemosynthesis theory, not cited as a weakness. So, in fact, author says if smokers are found in the vicinity. This was a conditional statement made in the passage. Another difficulty is that similarly dense populations of large deep sea animals have been found in the proximity of smokers, blah, blah, blah. Unless smokers are consistently located, unless. So it's a conditional statement. If not, he's not making a fact statement. It's only a conditional statement. Therefore, D is factually incorrect. Finally, all right. So question number 5. So question number 5. The last question. Which of the following, if true, would most weaken the author's argument? Now, please note. Now, please note. This is a critical reasoning. This is a critical reasoning question. Critical reasoning. And the correct answer will be hypothetical in the question itself says which of the following hypothetically the answer will not be found in the passage. Which of the following if would weaken the author's critical reasoning. What is the author's argument? What is the author's argument? For such questions, always write down the author's argument. So that you know what you're looking for. So what is the author's argument? That author's argument is photosynthesis produces food particles which get advected, drifted, they get moved towards the vent areas and feed the vent community. This is the author's argument. Now the question says weaken this argument. In order to weaken this argument, please note we'll have to prove that any part of this chain is problematic. And there's a barrier. There is something wrong with this chain. If I can find out some problem in this chain, then I can weaken the author's argument. Option A. The number of large animals found in the non-vent regions of deep sea is not high. Even if it is not high, there are some of them. And how are they surviving? Author says bacteria is not available for them. Bacterial chemosynthesis therefore is not available. So even if the number is low, they're still surviving. There has to be some alternative source. So probably advection is in fact the source of food for them. Author's argument is not weakened. Okay. Warm water vents with phenomenal amount of bacteria are often present in the vicinity of smokers. Not always. And this part author has already considered that extremely hot vent areas called smokers, if they are in their vicinity, if they have hospitable climates also. Even so, it is not 100%. It cannot be consistently. That's what he says. Unless smokers are consistently located, more hospitable temperatures, warm water. Unless they're consistently located. So basically, they have to be always present in the vicinity of smokers. Not that's a problem. It does not weaken the author's author himself conceded this point. Concession was given by the author. The movement of water associated with areas in and around the deep sea vents with relation to the oceanic surface is outward rather than inward. Please understand what this choice says. It says the movement of particulate matter, food particles, or any particulate associated with vent areas with relation to oceanic surface is outward. This is a deep vent inside the sea, and this is the surface. Particles are moving from the vent to the surface rather than from the surface into the vent. That is not happening. So this is not happening. Basically, this part of the chain, that advection moves the food particles, these food particles into the vent area. Part of the chain is therefore author's argument. This was the author's argument. Author's argument stands nullified nullified, it stands vitiated. Correct answer C. Correct answer C. Nice question, this one. You'll have to, guys, for critical reasoning questions, you have to first understand the idea. There's no shortcut. You'll have to imagine the chain of discussion. You'll have to write it down. And then you'll have to first think what would weaken this chain. Anything that disturbs the chain. And then you have to read the answer choices to be able to answer the questions better. Okay. D is again irrelevant. It does not have any impact on the author's work. A considerable number of large animals. In fact, it's not irrelevant. It strengthens the author's argument rather than weakens it. If a considerable number of large animals are present in the non-vent regions, then clearly author's argument stands supported that bacterial chemosynthesis supply, and it is something else which is probably advection is support. I hope you enjoyed, guys. If you like the effort that we are trying to put in for you, like these videos, share them with your friends, and spread the word about VARC 100. Thank you very much. Until next time, bye bye.